An autonomous AI agent just bankrupted its operator. Not metaphorically, we are talking actual financial ruin, all because the system was tasked with something that seemed completely harmless, scanning a network called DN42. What started as a curiosity-driven exploration spiraled into thousands of dollars in runaway EPI charges, and here's the wildest part: the AI wasn't hacked, wasn't being malicious, and nobody made a single coding error in the implementation. It was just following its instructions perfectly, too perfectly. The system did exactly what it was asked to do. It just never stopped. This is a wake-up call for anyone building or deploying AI agents, because the real danger isn't always the AI doing something unexpected or going rogue. Sometimes the danger is the AI doing exactly what you asked it to do, just continuing forever without hesitation. And here's where it gets interesting. The operator thought they'd built in safeguards. They thought they had limits and cost controls in place. They were wrong, completely and catastrophically wrong. This story reveals a blind spot in how we are currently building autonomous systems, and it's a mistake that's becoming increasingly common as AI agents get more sophisticated and more independent. If you're working with AI at all, this is important. DN42 is a decentralized network. Think of it like the internet, but completely isolated and private. It's a learning playground where networking enthusiasts test concepts without affecting the real world. Thousands of people operate nodes on DN42, experimenting with routing protocols, security techniques, and network administration skills. It's essentially a giant sandbox for people who love networking and want to learn without consequences. The person in this story was running what's called a network scanner, a tool that probes networks to discover what systems exist, what services are running, and how everything's connected together. In the real internet, network scanning is a crucial skill for security researchers and system administrators trying to understand their infrastructure. So this operator decided to run an automated scanner against DN42 to map the network topology, a completely legitimate learning exercise. The goal was innocent: document the structure of this decentralized network, see how it's organized, understand the patterns of how nodes connect to each other. It's the kind of project any networking student might take on to build their skill set. But here's what they didn't anticipate: their automation setup was going to cost them dearly. They built an AI agent to handle the scanning process, thinking it would be smart enough to manage the task efficiently and keep costs reasonable. That assumption proved to be catastrophically wrong. Here's the technical setup. The operator used a large language model AI agent, a system designed to follow complex instructions and make smart decisions autonomously. The agent was given a clear goal: scan DN42 and gather information about the network's structure and services. To accomplish this mission, it would need to make EPI calls to various web services and tools. These EPIs would help map the network, look up information, and document findings. Seems reasonable on paper, right? The critical flaw was in the feedback loop. The AI agent was given unlimited access to make EPI calls. There were no rate limits, no cost caps, and no kill switches built in. The agent would use an EPI to discover one network node, then decide it needed more information about that node, so it made another call, then another, then another. Each call cost money, sometimes a few cents per call, sometimes considerably more. The AI kept making calls because it kept discovering more things needing investigation. It was pursuing its goal with perfect logical consistency, never questioning whether each investigation was financially sustainable. The system had zero understanding of cost. There was no budgeting mechanism, nothing saying stop here and reconsider. But wait, there's something nobody's talking about. The operator built this system during their free time, without anticipating how compound EPI costs work at scale. So what's the actual cost we are talking about? The blog post detailing this disaster didn't reveal the exact final bill, but it was enough to describe as bankrupting. We are talking hundreds of dollars, possibly over $1,000. Some EPI providers charge anywhere from 10 cents to 50 cents per EPI call, and others charge even more for premium lookups. Imagine the AI making 2,000 EPI calls per hour, not unreasonable when it's aggressively gathering network data. That's hundreds of dollars per day. The operator ran this for 24 hours before realizing what was happening. Each EPI call was adding up silently in the background while the AI agent pursued its task with relentless efficiency. Think about it this way. If a single EPI call costs 25 cents and the agent makes 100 calls per hour, that's $25 per hour. Over 24 hours, that's $600, and that's if it stops there. In reality, the numbers could have been much worse. The operator was making assumptions about how many EPI calls would be necessary. They were completely wrong about the scale. Some operators reported similar incidents where costs hit the thousands of dollars because they underestimated how aggressively an autonomous AI agent would consume resources. The lesson is brutal. If your AI system can make expensive requests and you don't have hard limits, the costs won't just surprise you, they'll obliterate your budget. This isn't the first time someone's been blindsided by AI costs. Last year, a developer deployed a chatbot using OpenAI's EPI without rate limiting. The chatbot got hit by a bot attack. Thousands of requests flooded in, and the bill was so staggering the developer had to disable the entire service immediately. Another incident involved an image generation bot on social media that went viral. 100,000 requests in a day multiplied by the image generation cost equals tens of thousands of dollars vanishing in 24 hours. A GitHub user deployed a machine learning model that was retraining itself continuously, making EPI calls for data enrichment every single cycle. They woke up to a bill for several $1,000s without realizing it. The common thread? None of these were security breaches or hacks. They were all cases where the system was working perfectly, doing exactly what it was designed to do, just without any financial boundaries. The difference between this DN42 scanning story and these others is that DN42 was a deliberate choice to deploy an AI agent without safeguards, while many of the others were oversights. But the outcome's the same. Here's the kicker. Most developers who have used AI EPIs for more than a few months have had at least one moment of panic looking at their bill. This is becoming industry standard, and that's the part that's truly concerning. This incident exposes something critical about how we are building AI systems. We've created agents that can make autonomous decisions and take actions, spending money, making requests, consuming resources, but we haven't built corresponding safeguards into the fundamental architecture. Most AI frameworks focus on capability and speed. They assume humans will add safety limits, but humans forget. Humans miscalculate. Humans don't anticipate edge cases. And when you've got an agent operating independently, 24 hours a day, making decisions without human oversight, forgetting becomes expensive. The deeper issue is that AI models themselves have no concept of cost, budget, or financial responsibility. They can't understand that 100,000 EPI calls might bankrupt their operator. They can't value money because they've never had to survive in a world where resources are finite. They're optimized to complete tasks, not to balance task completion against financial sustainability. For advanced AI systems making decisions in other domains, autonomous vehicles, trading systems, resource allocation, this same blind spot creates liability. What if an autonomous vehicle's navigation system decided to take the most thorough route, making countless sensor readings and calculations, not understanding that each computation drains battery and costs money? What if a trading algorithm pursued profit optimization without hard stops on transaction costs? The DN42 story is a warning. And this is where it gets complicated. We haven't figured out how to solve this systematically. So how do you prevent your AI agent from bankrupting you? Here's the concrete checklist. Number 1, hard cost limits. Before deploying any AI system that can make EPI calls, set a monthly budget cap. Most cloud providers allow you to set spending limits that'll automatically pause your service if costs exceed a threshold. Set it conservatively. When you're deploying an unfamiliar agent, start with a very low limit, maybe $20 or $50, then increase it only after you've monitored the actual costs for a week. Number 2, rate limiting. Restrict how many EPI calls your agent can make per minute, per hour, per day. Don't just request data as much as you want. Implement queues and throttling so requests are spread out and observable. Number 3, logging and alerts. Track every single EPI call your agent makes. Log the cost, the timestamp, the endpoint. Set up alerts that notify you if costs exceed a certain threshold per hour. Don't wait for the bill. Watch it in real time. Number 4, timeouts and resource budgets. Set hard time limits on agent operations. If a task should take 2 hours, cap it at 3 hours maximum and have it fail gracefully if it exceeds that. Number 5, human approval gates. For expensive operations, require explicit human approval before the AI agent proceeds. Don't let it operate completely autonomously on decisions that cost money. And number 6, test in isolation. Before deploying an autonomous agent to production, run it in a controlled test environment with limited EPI access and monitor its behavior obsessively. The DN42 operator skipped all of these steps. Here's what this story means for you. AI agents are becoming more capable and more independent every month. We're deploying systems that make autonomous decisions, take actions, and allocate resources without explicit human permission for each decision. That's powerful and it's exciting, but it requires a completely different safety mindset. The DN42 bankruptcy wasn't a failure of the AI model. The model worked perfectly. It was a failure of the system architecture. It's a reminder that capability without constraints is just risk on a timer. If you're building AI systems, you need to treat financial boundaries the same way security researchers treat security boundaries. Assume worst case, implement multiple layers of defense, and never trust the system to regulate itself. If you're deploying AI in any capacity, whether it's EPI-heavy applications, autonomous workflows, or decision-making systems, start asking uncomfortable questions. What's the worst-case cost if this system runs unchecked? What happens if it loops? What happens if it finds an edge case I didn't anticipate? How do I kill it if it goes wrong? These aren't paranoid questions. They're essential questions that the DN42 operator should have asked before hitting deploy. And they are questions the whole industry needs to answer as AI systems get more powerful, more autonomous, and more integrated into our infrastructure. Stay critical, stay cautious, and stay vigilant.